On May 31st, 2013, a tornado touched down near Oklahoma City. Within minutes, it became the widest tornado ever recorded on Earth. Not half a mile wide, not 1 mile wide. 2.6 miles across, at its peak, the storm was so large that drivers on nearby highways couldn't even see its edges. Rain wrapped around the circulation, hiding the funnel completely. To many people on the ground, it looked less like a tornado, more like an entire wall of rotating storm clouds moving across the plains. Storm chasers followed it at first, just as they had done with hundreds of tornadoes before. But the Reno storm began behaving in ways no one expected. The tornado suddenly expanded outward, swallowing entire stretches of highway. Its path shifted without warning, turning directly toward the people trying to escape. Inside the storm, smaller vortices spun like invisible blades, each capable of producing some of the strongest winds ever measured on Earth. And for several experienced storm chasers tracking the tornado that afternoon, the realization came too late. They were no longer
Radar
chasing the
shows
storm.
rotation
They were
intensifying.
already inside it.
Copy that.
The
We should
Reno
reposition
tornado
southeast.
formed on the open plains of central Oklahoma, a place where people thought they understood tornadoes. This was not unfamiliar territory. This was Tornado Alley. Every spring, warm, moisture-rich air from the Gulf of Mexico sweeps north across the plains, while cooler, drier air pushes east from
To get
the
a
Rocky
supercell
Mountains.
thunderstorm to produce
When
a
those air
significant
masses
tornado
collide,
that has an
the
erratic
atmosphere
path,
over
there are a
Oklahoma
few key
can become
atmospheric
violently
conditions.
unstable, producing some of the most powerful thunderstorms on Earth. People here live with that risk. Meteorologists track it, storm chasers study it, communities prepare for it. Tornadoes are feared in Oklahoma, but they are not rare. They are part of the landscape, part of the season, part of the region's identity. And because of that, this was also a place where many believed the rules were known. Supercells formed, funnels dropped, storms moved northwest, chasers positioned themselves.
The sheer width
Scientists
at this
collected
altitude is
data.
unprecedented.
The danger
Look
was
at the
real,
velocity
but it was a
coupling here.
danger people
And the
believed they could
subvortices are
breathe.
clearly
On
visible
May
within
31st, 2013, the storm west of Oklahoma City appeared to begin within those familiar rules. But inside that supercell, the atmosphere was already building a tornado that would behave in ways even
The wind shear
experts
also
did not
played a big
expect.
role in what made this
Inside
tornado
the tower
behave
of
erratically.
supercell west of Oklahoma
Low-level
City,
winds were observed
powerful
south-southeast.
forces were already colliding high above the ground. Warm, moisture-rich air was rising rapidly from the surface, feeding the storm like fuel into a giant engine. At the same time, strong winds several kilometers above the ground were blowing in a different direction, and at much higher speeds. Meteorologists call this wind
The
shear.
combo of high instability
When
and strong
rising
wind
air
shear
meets
gave
strong
the
wind
parent
shear,
storm a
the
very wide
updraft inside
updraft.
the storm begins to rotate. That rotating column of air becomes what scientists call a mesocyclone, the spinning heart of a supercell thunderstorm. Most tornadoes form when that rotation tightens into a narrow funnel, descending toward the ground. But the Reno storm was behaving differently. Instead of tightening into a small circulation, the rotating core of the storm began spreading outward across a much larger area. Radar later revealed
Look at
that
the
the
velocity
circulation
spike here,
beneath
right
the
in the
storm
hook.
was
It's much
expanding
wider than we
rapidly,
thought at
growing
the time.
wider and more
The
complex
shear
with
was
every passing
unprecedented
minute.
at this range.
Inside
Yeah.
that enormous
Especially in a storm
rotating
that was
system,
catching many of the
smaller
experienced
subvortices
chasers
began
off guard.
spinning around the center of the storm like satellites. Each one of these smaller vortices could produce violent winds capable of destroying vehicles and structures. And unlike the classic image of a tornado, a single visible funnel, many of these vortices were hidden inside heavy rain, which meant that the tornado was far larger than it appeared. Drivers looking at the storm could see
it's coming right for us!
but the true circulation
keep it on the
extended
road. Brace
miles
yourself.
beyond the visible funnel. And as that circulation continued expanding
Positions
across
left
the
of the
plains,
mean motion
the
were
storm was
certainly
becoming
dangerous.
something even experienced
Positions
storm
left.
chasers
The data shows
had
strong
rarely encountered
rotation
a
right
tornado
here.
so large
But the
and
visual
unpredictable
suggests it's
that its
further
path
north.
could
I don't
change
like how
faster
wide this is
than
getting.
people trying to escape it. On the afternoon of May 31st, 2013, dozens of storm chasers were already spread across the plains
We have
west of
rapid
Oklahoma
intensification
City,
on the radar. We're
watching the
running out of time.
supercell build over the horizon.
I see the inflow jet. Hang on, we're
Among
cutting
them
south now.
was Tim Samaras. For years, Tim Samaras had done what very few people on Earth were willing to do: move closer to violent tornadoes, not for spectacle, but for science. He believed that if researchers could understand tornadoes better, how they formed, how they changed, how their winds behaved near the ground, then one day that knowledge could help save lives. That day, Tim Samaras was not alone. With him were his son Paul Samaras
Moving
and
east-northeast
fellow
at
researcher
15.
Carl Young. They were part of the
hold
Twistex
this
team,
road for
one of the
another
most
few miles.
respected field research groups in storm science. Their work depended on timing distance and calm judgment. They had done this before, many times. At first, the El Reno tornado
We have
looked like
confirmed
something
rotation
they could
on the radar.
manage. From the road, the
Acknowledged.
funnel appeared
Maintaining
narrow
parallel
enough to
track.
The storm looked dangerous, but familiar, the kind of storm that experienced researchers knew how to read. Then it began to change. The circulation started spreading outward much faster than anyone expected. Rain wrapped around the tornado, swallowing its edges and turning the storm into a dark, moving wall. Roads that looked clear only moments earlier were suddenly far too close to the circulation. Inside the vehicle, Tim Samaras, Paul Samaras, and Carl Young were no longer just observing the tornado. They were trying to understand where it really was. And that had become terrifying, difficult, because the visible funnel was no longer the whole storm. The storm was wider than it
shifted.
looked,
We're running
closer
out of
than it
road.
looked.
Go,
Moving
go, go!
differently
We have to
than it
beat it
should.
to the intersection!
For men who had spent years studying tornadoes, this was the moment when knowledge stopped feeling like protection. And out on those open Oklahoma roads, Tim Samaras, Paul Samaras, and Carl Young
can't hold
were
it.
beginning to
It's
face the
pushing me off the
possibility
road.
that the storm they had come to study
Hang on.
was now turning toward them. As the El Reno tornado intensified, the storm expanded into something far larger than anyone on the ground had expected. Radar data later showed the tornado growing to nearly 2.6 miles wide, a rotating circulation so large that many drivers on nearby highways could no longer see where the storm began reporting. Inside that massive circulation, several smaller subvortices spun rapidly around the center of the tornado. Each of these rotating cores carrying extreme winds capable of tearing vehicles apart, and they were moving unpredictably.
Intense
Instead of
chaser
following a steady
convergence
path
I'd
across
ever
the
seen in my
plains,
10
the
years of
tornado
chasing.
suddenly shifted
But once the
direction.
storm cycles
Most
a new
tornadoes in
updraft,
Oklahoma
that
move
process
northeast,
separates
but
the
El
tornado from
Reno
the main
tornado began
mesocyclone.
turning east, directly toward the roads where many storm chasers were trying to escape. Heavy rain wrapped around the storm, forming a dense curtain that hid the true size of the circulation. Drivers looking ahead could see only dark clouds and sheets of rain. The tornado itself was almost invisible. By the time some storm chasers realized how wide the circulation had become, they were already inside it. Vehicles began accelerating along rural highways, trying to outrun the storm. But the wind speeds inside the tornado were increasing rapidly. Radar later measured some of the strongest winds ever recorded in a tornado, more than 295 miles per hour. On the open plains west of Oklahoma City, the atmosphere had turned into a rotating machine of violent air currents.
Spreading across
And for
the
several
highway,
storm chasers
the true
caught
width
on
is
those roads,
unprecedented.
the storm was now closing in faster than they could escape. When the El Reno tornado finally weakened later that evening, the storm had carved a wide path across the plains west of Oklahoma City. The tornado's circulation had reached a record 2.6 miles in width, making it the widest tornado ever documented. Vehicles along several rural highways had been rolled, lifted, or thrown into nearby fields. In many cases, the destruction occurred not in towns or cities, but along open roads where storm chasers had been trying to outrun the storm. By the time the tornado dissipated, 8 people had lost their lives. Among them were Tim Samaras, Paul Samaras, and Carl Young, 3 of the most experienced tornado researchers in the world. For decades, Tim Samaras had studied violent storms in an effort to better understand them. Yet even for someone with that level of experience, the El Reno tornado proved impossible to fully anticipate. Several other storm chasers survived only by turning away from the storm moments before the circulation reached the roads they had been traveling on. In a storm, this large survival sometimes came down to seconds and a single change in direction. In the years after El Reno meteorologists studied the storm with extraordinary care, radar data showed a tornado
velocity
unlike
couplet
the
is
simple
intensifying,
funnels.
but the
People
visibility is
imagine
zero.
a vast
It's moving
rotating
directly
system
toward the
filled with
intercept
hidden
point. We're too
subvortices,
exposed here.
sudden shifts in direction, and wind speeds so extreme that even experienced observers on the ground could not fully read its true shape in real time. And that is
Even
the
with the
real
high-resolution
lesson of El
data,
Reno.
the atmospheric
It was
conditions
not just the
reached a
widest
rare
tornado
extreme.
ever recorded.
The models failed
It
to
was a
predict the
reminder
rapid
that nature
spin-up
does
right
not
here.
follow the diagrams we draw after the fact. People in Oklahoma understood tornadoes. Scientists studied them. Storm chasers dedicated their lives to tracking them. And still this storm found the gap between knowledge and reality. Because understanding a force of nature is not the same as controlling it. And sometimes the most dangerous disasters are not the ones we fail to notice, but the ones we think we already understand.